When the F-22 Raptor entered operational service in 2005, it represented a generational leap in aerial warfare. With a radar cross-section roughly comparable to a steel marble and a top speed surpassing 1,500 miles per hour, the aircraft was essentially a ghost in the sky, a machine that fused stealth, velocity, and agility into a package no adversary could match. Pilots who flew it spoke about it in near-reverent terms. Yet behind that formidable reputation sat a strategic vulnerability that Pentagon planners were reluctant to discuss openly. The Raptor couldn't go very far. The aircraft was designed for theater environments like Europe or the Middle East, where American air installations are relatively close to potential flashpoints. The global threat environment, however, has undergone a profound transformation. China, now the United States' most consequential strategic competitor, sits thousands of miles across the Pacific Ocean. The F-22, for all its battlefield dominance, simply lacked the legs to project power across that kind of distance without leaning on aerial refueling support. That dependence on tanker aircraft carries serious operational risks that go beyond mere inconvenience. Tankers are enormous, slow-moving, and plainly visible on radar. In an opening hours assault by a peer adversary, they would almost certainly be among the first targets eliminated. Strip away the tankers, and the F-22's effective combat radius collapses, rendering it largely irrelevant across the vast distances of the Indo-Pacific theater. Lockheed Martin and Air Force planners recognized this structural problem years ago and began engineering their way out of it. What emerged from that effort is now being called Raptor 2.0, solving the range problem without sacrificing invisibility. The headline feature of the Raptor 2.0 upgrade is a breakthrough fuel system, a set of low-drag, stealth-compatible external tanks that solve a problem engineers once considered fundamentally unsolvable. For decades, external fuel tanks and stealth design were considered mutually exclusive. Traditional drop tanks dramatically inflate a fighter's radar signature, not just through the tanks themselves but through the pylons required to attach them. Even if a pilot jettisoned the tanks before entering contested airspace, the mounting hardware left behind created radar-reflecting edges that could compromise detection avoidance. Stealth aircraft operated under a hard constraint: trade range for survivability, or trade survivability for range. Lockheed Martin's engineers found a way to dissolve that constraint entirely. The new tanks are built using the same faceted, radar-absorbing geometry applied to the F-22's own airframe. They don't compromise the aircraft's stealth profile, don't require jettisoning before entering hostile territory, and perhaps most surprisingly don't impose meaningful handling restrictions. According to Katie Cesarino, vice president of the F-22 program at Lockheed Martin, pilots can execute the full range of combat maneuvers they'd perform on a clean aircraft, even with the tanks fully attached. The operational consequence is dramatic: a combat radius increase of up to 850 nautical miles. To put that in context, that's not a marginal performance gain achieved through incremental engineering. It's a wholesale expansion of which missions the F-22 can fly, which targets it can reach, and how far into heavily defended airspace it can penetrate while remaining undetected. The tanks were publicly unveiled at the Air and Space Forces Association Warfare Symposium in February 2026, where Lockheed Martin displayed a production representative model indicating that engineering has been finalized and active testing is underway. Hunting stealth aircraft with heat, not radio waves. Of all the enhancements bundled into Raptor 2.0, perhaps none carries more strategic weight than the addition of an infrared search and track system, universally known by its acronym, IRST. China's J-20 and Russia's Su-57 were both engineered with a single overriding priority: defeating radar-based detection. Their airframes are meticulously shaped to absorb or scatter radar energy, returning so little signal to conventional detection systems that they effectively disappear from screens. Against a standard radar array, these aircraft present a formidable detection challenge. IRST attacks a weakness that no amount of airframe geometry can eliminate: thermal radiation. Every jet engine operating at combat power burns enormous quantities of fuel and produces a substantial heat plume in its exhaust. High-speed atmospheric friction generates additional thermal energy across the aircraft's entire skin. Physics is unforgiving in this respect. Heat cannot be shaped away or absorbed like a radar signal. It radiates outward regardless. The IRST pods integrated onto the F-22's wings detect these heat signatures entirely passively. The system never transmits a signal of any kind. It doesn't ping, sweep, or broadcast electromagnetic energy. The F-22 builds a targeting picture in complete electromagnetic silence. A J-20 pilot trained to interpret the absence of a radar lock as a sign of safety would receive no indication whatsoever that a Raptor was already tracking him. The system's architecture also enables a powerful networked capability. The pods are mounted at extended positions along the wings to maximize the sensor baseline. The wider the separation between sensors, the more precise the geometric triangulation of a target's position. More significantly, multiple F-22's operating information can share sensor data across the entire flight. An aircraft flying in a completely clean stealth configuration, carrying no pods at all, still receives the full sensor picture from wingmen who are equipped. The tactical awareness of the entire formation improves simultaneously, multiplying the combat value of each individual aircraft. Layered defense across multiple domains. Raptor 2.0 also incorporates a new infrared defensive system, or IRDS, alongside a substantially upgraded radar suite and enhanced electronic warfare capabilities. Taken together, these additions give the aircraft a layered defensive architecture designed to operate simultaneously across multiple threat domains. Electronic warfare on modern combat aircraft serves a diverse range of functions, jamming adversary radar emissions, disrupting the guidance systems of incoming missiles, feeding false data to enemy sensors, and protecting against both radar-guided and infrared-guided threats. The F-22's original electronic warfare suite was designed against Cold War-era threat standards, a baseline that no longer reflects the sophistication, speed, or seeker technology of current adversary weapons systems. The upgraded suite addresses that gap directly. Combined with the aircraft's existing stealth characteristics, the enhanced electronic warfare capability means adversaries must now overcome multiple independent defensive layers before they can successfully target a Raptor. Defeating one layer doesn't expose the aircraft, it simply forces an attacker to contend with the next one, closing a gap that should never have existed. One of the more quietly embarrassing limitations of the original F-22 was an absence that the Air Force rarely highlighted. The aircraft never received the helmet-mounted display system. The F-35, various upgraded F-16 variants, and most modern international fighters had incorporated helmet-mounted targeting for years, allowing pilots to designate weapons simply by looking at a target. The F-22, superior in nearly every other measurable respect, lacked this basic capability. Raptor 2.0 corrects the omission. In close-range maneuvering engagements, the tactical value of helmet cueing is difficult to overstate. It allows a pilot to engage targets at extreme off-boresight angles, aircraft that are off to the side, or even partially behind the fighter, without first needing to maneuver the aircraft's nose onto them. An opponent who must physically turn to achieve a firing solution against a target is burning time, energy, and geometric advantage that a helmet-equipped pilot doesn't need to spend. In a turning engagement between otherwise evenly matched aircraft, that difference frequently decides the outcome. The human-machine combat team, the most forward-looking dimension of Raptor 2.0, and the one receiving the least public attention, is a capability that fundamentally changes what a single F-22 can accomplish: the ability to serve as a command and control node for MQ-20 Avenger unmanned combat aircraft. The MQ-20 is a stealthy, jet-powered drone capable of carrying weapons, conducting ISR missions, and operating alongside manned fighters in contested airspace. Under the Raptor 2.0 framework, a single F-22 flying deep inside enemy-controlled territory, radar invisible, thermally quiet, electromagnetically silent, can simultaneously direct a formation of autonomous combat drones as a coordinated strike package. This concept, known formally as Collaborative Combat Aircraft Teaming or CCA, represents a structural shift in how air power is organized and projected. A single pilot in a single cockpit effectively commands multiple strike platforms at once, dramatically expanding offensive capacity without proportionally increasing the number of human lives placed at risk. The drones absorb threat exposure and perform functions that would otherwise require additional manned aircraft. While the F-22 maintains command from a position of stealth, the pilot's cognitive load increases, but the combat output of the entire formation multiplies. This isn't a concept paper or a research program. The F-22 is already being modified to make it operational. Investment and timeline. As of early 2026, testing of the low-drag stealth fuel tanks was projected to reach completion in late 2025, with deliveries to operational F-22 squadrons to follow. Qualification testing for the IRST pods is scheduled to run through mid-2026. The Air Force has not publicly announced firm dates for full operational capability, but the hardware exists. The aircraft are in active service, and testing is ongoing across multiple systems. The financial commitment reflects institutional seriousness. The Air Force requested $90 million in dedicated Raptor 2.0 funding within its 2026 budget. That figure signals a clear organizational decision to retain the F-22 as a frontline combat asset for the foreseeable future, rather than pursuing the accelerated retirement that some analysts had recommended. The bridge to the F-47. Raptor 2.0 doesn't exist in isolation, it exists in context. In March 2025, President Trump announced that Boeing had been awarded the contract to develop the F-47, the designated next-generation air dominance platform and the Air Force's intended sixth-generation successor to the F-22. The F-47 remains years from operational service, and the transition period between generations represents a potential window of vulnerability. Raptor 2.0 was designed specifically to close that window. By extending the F-22's operational relevance and dramatically expanding its combat capabilities, the Air Force maintains uncontested air superiority throughout the transition, ensuring that when the F-47 eventually enters service, it inherits an environment of dominance rather than stepping into a gap. This sequencing reflects deliberate long-term planning. The United States is not reacting to a threat that has already materialized. It is extending an advantage before that advantage can erode. What it means for the global balance. China has invested heavily in its stealth aviation program over the past 2 decades. Russia continues developing fifth-generation platforms despite resource constraints. Both nations have made closing the gap with American air power a central defense priority. Raptor 2.0 widens that gap at precisely the moment adversaries believed they were narrowing it. The integration of extended stealth range, passive infrared detection, networked multi-aircraft awareness, drone command architecture, layered electronic defense, and helmet-mounted targeting into a single upgraded platform represents a level of systems integration and operational synergy that no other nation's air force has achieved. No peer competitor currently operates anything comparable, not in stealth geometry, not in passive detection, not in the human-machine teaming architecture now being embedded into operational F-22 squadrons. The original Raptor established what air superiority looked like for its generation. Raptor 2.0 rewrites the definition for the generation that follows.